My dear students, by now you have an idea about the unconstrained as well as constraint optimization problem. Now today we are going to discuss about maximum value functions and indirect objective functions. Before proceeding further, let me give you a very common example. Suppose we consider a utility maximization problem. U is a function of x and y, where suppose x is the number of apples consumed and y is the number of oranges consumed. And suppose my problem is to allocate the consumption of apples and oranges so that my utility is maximized. And this is a constraint optimization problem because, as you know, my income is fixed and the prices are given. So let us suppose that initially my income is rupees 200. So my problem is to consume apples and oranges so that the utility is maximized. Now suppose if I consume 5 apples and 4 oranges, then my utility is maximized subject to the condition that my income is rupees 200 and the prices are fixed. So this x equal to 5, that is apples equal to 5 and oranges equal to 4. This is the optimal value of x and y, and we call this x star and y star. These are the optimal values of x and y. And these values of x star and y star gives me u star, which is the maximum utility that I can obtain. Now this x equal to 5 and y equal to 4 is contingent upon the fact that my income is 200. Now suppose my income increases, it becomes 250. Then definitely x star and y star will change, that is I will reallocate my increased income so that there is a change in the consumption of x and y. So we can say that x star and y star depends on the level of income as well. Again, if there is a change in the price of apple or oranges, then again there is a reallocation and the x star and y star values will change. So we can say that the optimal values of x star and y star depends on the parameters, that is the prices px, py as well as the level of income. So when we substitute these optimal values of x star and y star into the utility function, that is the objective function, we get the maximum utility value, that is u star. And as you can see that u star also depends on the parameters, because x and y at the level of optimality, x and y depends on the parameters, therefore the optimal utility also depends on the parameters. Now this value, this u star is called the maximum value function. Now so when we substitute the optimal values of x and y into the objective function, we get the indirect objective function, and this depends on the parameters. So now we can define the maximum value function. A max value function is an objective function where the choice variables have been assigned their optimal values. The optimal values of the choice variables are functions of the exogenous variables and parameters. Why are maximum value functions also called indirect objective functions? When the optimal values of the choice variables are substituted into the objective function, it indirectly becomes a function of the exogenous variables and parameters. Let us take an example. Maximize fxa, where x is the choice variable and a is a parameter. Now let x star a be the optimal choice function, then x star a satisfies the first order conditions, where you know the FOC is the partial derivative of the objective function with respect to x must be equal to 0. Now we define an indirect objective function as the value of the objective function where the choice variable is chosen optimally. That is, if fxa is the objective function, then the indirect objective function f star is the value of f when x is equal to x star as a function of a. Therefore, we write f star a is a function of x star a and a, which means that f star is a function of the parameter a only and not a function of x. So in this indirect objective function, the choice variable is not free. X is always set to maximize the objective function. So we can see the difference between the objective function and the indirect objective function. First, in objective function, the x or the choice variable is free to move, but in the indirect objective function, the choice variable is always set to maximize the objective function. Secondly, in the objective function, the function depends on both the choice variable and the parameter, whereas in the indirect objective function, it depends only on the parameter. Now let us take another example from consumer theory. Maximize uxy subject to pxx plus pyy equal to I, where I is the level of income, and here we maximize with respect to x and y. The Lagrange function is defined by L equal to uxy plus alpha into the constraint, where alpha is the Lagrange multiplier. Now taking the first order conditions, we have three conditions. Firstly, del L del x is equal to del u del x minus alpha d px equal to 0. Del L del y is equal to del u del y minus alpha d py equal to 0. And thirdly, del L del alpha is equal to I minus px xd minus py yd equal to 0. Over here, alpha d, as I said, is the Lagrangian multiplier. The superscript d is used to refer to the fact that these solutions are the consumer's demands. Now, by solving, the Lagrange multiplier gives alpha d is a function of px, py and I, and the demand functions are also the functions of px, py and I. Here xd and yd are the functions of the parameters, and they are called the uncompensated or Marshallian demand functions, because if there is a change in price, then the utility will also change. These functions are called uncompensated because if prices change, then utility will also change. Substituting these back into the utility function, we get the actual utility achieved as a function of prices and income. And this is known as the indirect utility function. So we have V, which is a function only of the parameters, that is px, py and I, is equal to u of xd, which is a function of px, py and I, and yd, which is again function of px, py and I. So this function actually says how much utility consumers are getting when they face the prices px and py and have a fixed income level of I. So students, this is all for today's class, and I hope that you have understood what I have tried to teach you in this tutorial. Thank you.